I personally would just prefer to watch the highlights on the news tonight than the whole address. All right. This is notes on 9.3. The assignment that goes with this tonight will be page 600. Does that sound right?
Yeah.
Okay. What you need out right now is notes worksheet 2A, B, and your unit circle. Okay. We are doing half angle and double angle formulas today, so let me show you where they are on your half sheet. Here's my attempt. This one is on the left towards the bottom. And this one is on the right towards the bottom. Okay? These will also come up a couple times again today, sum and difference. They're right across the middle, yes. And in the lower left corner down here are the squares of these guys, these first two up here. Okay, if you squared those, well, actually, that's not what they are, I don't think. Are they? No, they're not. They're just some other traits. We aren't going to use these, but the whole thing where you have to simplify, like trade, if it said something and you had to go back and forth between them, I assume you could do that with this one as well, okay? And I'll show you what I'm talking about in a minute, if that didn't make any sense. I'm talking about questions like these, okay? Where you just have to trade out something. You don't have to do anything with it, really. All right. Victor, what is your question?
Page 3, you said.
Nope, 2. Did I say 3? I'm sorry if I said 3. It's 2. 3 is on the homework check. You have to do 3, A and B. It's hard? Okay. Yeah, we're going to learn some of it now. The sign of alpha is -3/5, and it is located between pi and 3 pi over 2. So between pi and 3 pi over 2, tell us that it is in quadrant 3. If we draw the triangle with the x-axis in quadrant 3. Now, I need to be very clear on something. Angle alpha is actually the angle that takes you all the way around to here. Okay? When we talk about this triangle, we talk about the reference angle being here. And we do opposite over adjacent or whatever, okay? But the angle is what would take you all the way to the third quadrant. That's going to matter when we get down to these half angle ones. Okay. 2, sine of 2 theta. First we need to label our picture. Sorry, I got ahead of myself. Sine is opposite over hypotenuse. Which one of those is negative? The 3. And if we do quadratic formula, we get 4. So this is a 4 or not. It is negative because we went left and down in that quadrant, right? Okay, this one's an easy one. Sine of 2. The formula is 2 times the sine times the cosine. Does that sound right? So we need to do 2 times the sine is -3/5, and the cosine is -4/5. You can use your calculator if you want. You can put 2 over 1 and just multiply across the top and multiply across the bottom. Anybody know what we get? Yep, we get 24/25. And I'm trying to squeeze that in there ever so small. Okay? All right, cosine 2 theta. 3 different trades possible. Doesn't matter which one you pick, they'll all give you the same answer. I usually just go with the first one because it kind of gives me the common denominator right away. It's cosine squared minus sine squared, isn't it? Okay, I'm missing my thetas here, but you'll forgive me. Cosine of this squared, cosine is -4/5. Sine is -3/5. What do we have to do first? square them first. Be careful of order of operations. And when you square a fraction, you square top and bottom. So we get 16 over 25 minus 9 over 25 because they both become positive, right, when we square them? So then the minus becomes 7/25 when we subtract. Be careful you don't do something crazy like make your minus a negative here to a positive, because remember you're squaring it and all that kind of good stuff. I use that one, cosine squared minus sine squared, because I don't have to get a common denominator. It'll come out with the common denominator. All right? Now, cosine 2 has a crazy formula on here. It's 2 tan over 1 minus tan squared. But if we've already done the double angle for both sine and cosine, do we remember a shortcut from yesterday?
Ooh, it's just sine
Okay.
over tan, sine, cosine.
So this would be the sine of 24/25 needs to be divided by the cosine, which was 7/25. When we flip, oh, that was a 25 down there, sorry. When we flip this guy over, the 25s will cancel and we get 24/7. If we hadn't already done the double angle and the double sine and the double angle cosine, then it would have been faster to use this formula, but since we did, we're good. All right, you're back just in time to learn the tricky part, guys. We talked about that this is a third quadrant angle. So its value is somewhere between, I'm going to write the degrees just because we think better in degrees, okay? Third quadrant is 180 to 270. Everybody okay? That's where theta is when they, or alpha, sorry, it was alpha. But we, in these last three, are trying to calculate something that has to do with alpha over 2, which would be between 90 and 135 if I divided everything by 2. Okay, think about that for a minute. If I had a quadrant 3 angle that fell somewhere between 180 and 270, and I want half of it, it's going to fall between 90 and 135. Okay, a 90-degree angle and a 135-degree angle are up in here somewhere. What quadrant am I in? That's all I care about.
Second.
It would be somewhere in quadrant 2. All of these would fall in quadrant 2. Okay? Why do I care? Well, guess what? The formulas for these all say this, plus or minus. And you have to determine by the quadrant whether it's positive or negative. That's part of your assignment, okay, is to determine that. The sign in the second quadrant would be positive. If you need to remember this, all students take calculus. I just remember it's the y value is sine and y is positive in this quadrant. So this one is going to be positive. Cosine in quadrant 2 is going to be negative. And tangent in quadrant 2 is going to be negative. All right, so we took care of all that plus or minus business. Everybody okay with how we did that? We'll do a couple more so we can practice it. But now, the formula, the actual formula we need here, sorry, Michael, I'll turn that off, I know it. The formula, is it still recording? Yes, okay. I just worry about recording when I turn the microphone, or the volume off, but it's not the microphone, I guess. Okay. The formula for sine, if I remember right, is 1 minus cosine over 2. Did I remember correctly? Or is it 1 plus cosine? Sine is minus, okay? So if we plug our values in, we get 1 minus, the cosine from our triangle up here was negative 4/5. And it's all over 2. You can use your calculator if you don't like fractions. Don't type the square root in. But this would be 5/5, right? Minus a negative would be plus 4/5, which is 9/5. And then we have to take half of that or divide by 2. So it will become 9/10. Yep, it's way ahead of me. We have to square root. What's the square root of 9? 3, and the square root of 10 is not nice, irrational, and some idiot mathematician decided we needed to write that how?
3 square root of 10 over 10. Root for what?
So if I did those, but then the answer's still gonna be the same, right? I just have to figure out whether it's positive or negative?
Yes,
Cause I just put plus or minus, just like.
yeah. But if you already did those kind on your homework, you should be fine, as long as you did exact values and everything. The only thing I've had students do in the past is try to just type them in, get something, and no, that's not gonna be acceptable. All right, cosine of alpha over 2, same thing, but this changes to plus, doesn't it, guys?
Yeah.
When we're doing this one. So it will be square root of 1 plus negative 4/5, which is actually gonna be minus. So 5/5 plus negative 4/5 is 1/5. Divided by 2 means times a half. So we get 1/10.
Square root of 10 over 10.
Yep, but it's negative, don't forget. We already predetermined that it's negative in that quadrant. Last one. Can we be lazy?
Yeah.
Since we already did the half angle sine and the half angle cosine, we can just put this over this. Well, the square root of 10s over 10 are going to cancel out, and we end up with what?
1/3.
3.
3 square roots of 10 over 10. It's sine divided by cosine. I'll put the negative there.
No, it's
It's
negative.
negative 1/3.
Has to be.
No, the 3's on the top,
Oh no.
so it's negative 3.
Oh no, the 3 was in the sign. Never mind. You're right.
Yes.
Is it always in the same quadrant as the original problem?
No. No, if it's half, it generally moves quadrants. It always moves a quadrant, I think. Double angles are tricky, but if it's half and it's in the first quadrant, it'll stay.
Yeah, okay.
If it's half in the second quadrant, it'll move back. Fourth quadrant, between 270 and 360, take half, would be, yeah, they all move except the first quadrant, when you do half. Yeah. Double angles are tricky if you try to think about where it would move to, because it can move different places. When you double things, you get a bigger range of values, but you don't have to do that because there's no plus or minus on any of the double angle formulas. They'll just automatically be determined. All right, we are going to move on and talk about some quick trades here. There's a typo, guys. This is I'm gonna change this to an X. I'm not sure what we were supposed to do there, but I'm gonna make that an X because that's the kind of question you're gonna see on the homework and or the quiz. So if it said sine, cosine plus cosine sine, that's from yesterday. Do you find one that says sine, cosine plus cosine sine?
Yeah.
It's sine of A plus B, right? Only what's our A
5 over 2.
and our B?
X.
That's it. That's all I want you to write. This one's super easy. Says exactly that on your sheet, except we're going to trade it for a beta. Where does it say cosine squared minus sine squared?
Cosine to A plus B?
Nope.
I don't know.
Cosine squared minus sine squared is
Cosine 2 theta.
cosine 2 theta, or in this case, it's going to be cosine of 2 beta. Okay? This one, tan minus tan over 1 plus tan tan.
That's 10 A minus B.
Tan A minus B, only our A is just Greek and our B is just Greek. So it's tan alpha minus beta.
Oh, so we did the A, we did another thing because it actually had like terms of pi. Is that right?
We just traded it.
Yeah.
for the one that was on here.
I was confused, like, why we did like two different things for that and then one. different thing
We
for
didn't
that.
really, I just wrote out what the trade was, that's all. All right, D, this is a little bit trickier, but this is actually the kind that I usually put on a quiz or test. 2 sine cosine is traded for what?
That's sine 2 theta.
Okay, it says sine of 2 theta. But our theta is not just an x, it's a 3x. So we're gonna write the sine of 2 3x's, which can simplify to the sine of 6x. So try the next one on your own quick. Find that one and trade your theta for a 4 alpha. Anybody get cosine of 2 alpha after you divided it out or not?
I did.
Yeah.
It's a half angle. 4 alpha goes in there. And when you take half, it actually simplifies down to 2 alpha. Which, obviously, there's other trades for that because it's now a double angle, but we're just trying to simplify, not make it more complicated. All right, sine minus cosine cosine. Where's sine minus cosine cosine?
Isn't that sine A, cosine A plus B? No.
Oh, I'm reading it totally wrong. It is sine cosine minus cosine sine. Sine cosine minus
That's
cosine
sine
sine.
A minus B.
Okay, it is sine of A minus B, which would be sine of
30,
30 minus 40, which is the sine of,
negative
okay, and I would prefer you never left that answer, because on your sheet it says, is it an even or odd function? It's, I love how they call it, it's a relation. It's your odd relations, okay? I'm pretty sure my nieces and nephews think I am their odd relation.
Oh, so it's negative sine.
You can move the negative out front, yes.
No, not yet.
I get it.
All right, next one. Cosine, cosine plus sine, sine. Now I finally read one correctly, I think. Cosine, cosine plus sine, sine is cosine of A minus B. Is it minus? Plus. Plus, minus. Okay. I would expect you to simplify that, guys. You can use your calculator, 1/3 minus 1/4 if you want.
15?
No, I'm silly.
So it's pi over
It's
12.
4 twelfths minus 3 twelfths is,
1/12. Yay!
How dare you check?
you can use your calculator and type 1/3 minus 1/4, then you will get 1/12, and then you just need to remember to put the pi on. We good?
Oh, this is gross. Why? There's no point.
This is gross, okay? There's a bunch of these in the book. I did not assign them because it turns out just nasty, okay? If you take sine 3x, you can split it apart as x plus 2x. That seems pretty straightforward, right? Then if we did that, what is the sum formula for sine of A plus B, say?
Sine x cosine, cosine A cosine B plus cosine A cosine
Right,
B.
so that's what we're gonna do. Only instead of all of our A's, we're gonna write
X's,
X's, and instead of our B's, we're gonna write
2x.
2 X's.
Whoa.
Now, we're gonna look up here, and we're gonna trade these out.
Wait, isn't this supposed to be cosine 2x?
This one is a cosine 2x,
No, the second one. Why is it sine 2x? I thought.
because the sine sum formula says sine, cosine,
Roger
cosine,
that. I
sine?
got you.
Okay. What is a cosine 2x that we could trade for? There's three choices,
One
so,
minus 2 sine squared theta.
Oh my god.
okay, doesn't matter which one we trade it for. I'm gonna do the first one, I think. Oh, it's supposed to be an x, sorry. I don't care which one you do. This one, if we traded the sine of 2x, it would be traded for a 2 sine of x cosine of x.
Yes.
I vote we just stop there. We could distribute now.
No, why would we do that? Oh,
Why? Don't even, like, I don't have to write this, but still.
oh, wow.
It just hurts my eye.
It's not going anywhere pretty, is it? Okay?
What are we doing?
But there's nothing on any of the x's anymore. So I think if you had to do a derivative or something in calculus, I think you'd be able to do it because you don't have a 3 on that x anymore. I don't know. I don't remember. I'm just going to go with it's ugly. We're going to stop. I did not put any on the homework, okay?
Or tests or quizzes?
Or tests or quizzes, yes.
Or ACTs?
Back to, no, it won't be on the ACT either, I promise.
Oh, no, no, it's
On the back, I'm gonna skip around a little bit and let you do some of these, but could we talk about, let's talk about this one, number 2, real quick. Okay, number 2. Because it's a half angle, so we have to decide on the sign again. So let's make sure we have that part down, that plus or minus business. What quadrant is this in right now? If it's between pi over 2,
Quadrant.
pi over 2, and pi, means it's somewhere in quadrant 2.
You're like me then.
The tangent is opposite over adjacent. We need to make a determination about which one of those was negative.
Cosine's negative.
Okay, or x is negative,
Oh yeah.
okay? And anybody know this Pythagorean triple?
Six.
Okay.
You guys are good at this.
Everybody all right?
Sure.
Yeah, sure.
All right, the formula for cosine is plus or minus square root of 1 plus. Is that right, guys? Did I remember right or not?
You were
Yeah, that's
correct.
right.
Okay. And we need to determine whether it is the plus or the minus. If we are somewhere between 90 and 180, and we were to take half here, it says, we'd wind up somewhere between 45 and 90, somewhere in there. Okay.
So it's positive.
And in that first quadrant, everything is positive. So this is going to be a positive square root. Now let's plug our values in and be done. 1 plus the cosine from over here, which was
Is it negative 15 over 17?
all divided by 2. The 1 would be the same as a 17/17. 2/17 divided by 2, or 2/17 times a half is 1/17, I think.
Yeah.
Oh, yeah,
Square root, and we get, yeah, or something like that is right.
Well, 17's a good number.
17 is a nice prime number.
So the final answer is square root of 117?
No, square root of 17 over 17.
Oh, I could not see that because like, right where I was sitting, it's like, Marcos had perfectly numbers. I'm sorry.
It's all right, Mark.
Still your fault. Okay, well,
Mr. Biggers can move his desk over. All right, I'm gonna do number 3, and then I'm gonna do a couple at the bottom. Number 3 says tangent 2 theta. We have not done sine 2 theta or cosine 2 theta for this problem, and I personally think it would be more work to do those two than to just use the tangent 2 theta formula from the beginning. So this time I'm going to use 2 tan theta over 1 minus tan squared theta. You can do it the other way around if you want and see if you can beat me, but
Yeah, I'm good.
180 and 270. We just need the tangent for our formula over here. Negative 24 25ths. What's the tangent going to be? But it's positive 7 24ths, right? In that quadrant? Little painful, but you have a calculator. This is 7/12. This is 1 minus 49 over, anybody know 24 squared?
267.
Oh, 25 squared is what?
576. All right?
Yeah, I didn't know that.
So 576 over 576 minus 49 over 576. It's like 527 or something, I don't know.
527 over 576.
Okay?
And that does not.
7/12. We flip this over. This goes in here, I don't know, 12 goes into 576
Probably about
48 times.
Because 24 goes in there 24 times.
Yep. 7 times 48 is?
Are we sure?
525,064.
Okay, if you want to do it on your calculator, listen, you can type it all from here, guys. Type this in your calculator. Actually, you could have typed this as long as you put this around the bottom. And then do a math enter, enter, and it will work. As long as there's no square root, your calculator is good. Unless you get to like, I don't know how many, I don't know if it'll do a fraction that has like 5, just 5 places.
Like 10,000.
Like 10,000. I don't even know if it'll do 4 for sure, but I know it'll do this one. All right. I would like you to do some more practice at the top, but right now I would like to go over only 3 of the questions at the bottom, maybe 4, but you don't have to write all 4 of them down if you don't want. There's some real ugliness down here at the bottom. It helps if you think about, this is equation solving, okay guys? This is totally different, so please be paying attention. It helps if you think about how many solutions you're looking for. We could actually probably do this one with just thinking about the graph. A cosine graph starts up here and finishes by 2 pi. But this one has a period of what? What's 2 pi over 4?
Pi over 2.
Okay, so this one finishes once by pi over 2. Another one by what? Pi. Another one by 3 pi over 2. And another one by 2 pi. They want to know where it hits -1.
Pi over 4.
It is going to be exactly pi over 4 and all of those, okay? If we couldn't figure that, I'm going to do it algebraically, okay? Algebraically, you would say -1 equals the cosine of some value. You'd go to your unit circle. Where's the cosine -1? Where's, yes, it's pi, and every 2 pi after that. But I don't want to know what u is. I want to know what theta is, and theta is equal to, or u is equal to 4 thetas. So I have to divide everything by 4. So I get pi over 4 plus or minus, I'm going to leave that 2 pi over 4 n for just a minute. So the first one is pi over 4. After that, if I add 2/4, I get 3/4. If I add another 2/4, I get 5/4. So if I add another 2/4, I get 7/4. After that, I'm at 9/4, which is bigger than 2. So we had these 4 solutions. This one was really nice because it was -1. We could have just looked at the graph and probably figured them out, okay? If it's not -1 or 0 or +1, it's not so nice. All right, we're gonna try this one. How many solutions is this going to have? What's that graph gonna do? It's a sine, so normally it does this between 0 and 2 pi. But what's 2 pi over 1/4? 8 pi. That means this sine graph does not finish until 8 pi. So at 4 pi, it's only got positive values. At 2 pi, this is the little piece we're talking about. So how many times do you think it's going to hit square root of 3 over 2?
Come on.
I'm thinking it's going to have one answer. Okay? All right, I'm going to start with the sine of u is square root of 3 over 2. Where is the sine square root of 3 over 2? Give me both of them. Just sine is square root of 3 over 2 at pi over 3. And
Which is pi over 3. I mean, wait.
okay, that's what u is, but what is our u really?
Are you really?
Okay. Now, if we multiply all the way through by a 4, it's going to say plus or minus 8 pi n. Is that going to fall anywhere in our window? No. So we have 4 pi over 3 as one of our answers. If we multiply this by 4, we get 8 pi over 3. Too big, right? We said we were only looking for one answer. What's our one answer?
4 pi over 3.
Right. I want to do one more, a shift one with you, and I think I'm going to do that one, and it won't take me 10
This
minutes.
is 12.
I want to do one that's kind of, or really icky,
All the same.
but you guys don't need to write this one down, because I promise I'm not going to ask you this. I'm not going to ask you, honestly, I will tell you I'm not going to ask you any of these, but I'm going to do this one, okay? Just watch. Put your pencil down, relax. It's not worth writing it down. But I want you to think about the answers here. What is the period, guys, what is the period for this graph?
It is 6 pi?
2 pi over 3,
Oh, oopsie.
okay? It's a cosine, so here's 2 pi over 3, 4 pi over 3, 6 pi over 3, which is really what? 2 pi. So how many times do you think it's going to hit square root of 2 over 2, a positive value, by the time we get to 2 pi?
1, 2, 3, 4, 5, 6, 6.
6 times, it looks like, right? All right. I'm going to do the u substitution. I just need to tell me where the cosine is square root of 2 over 2, guys.
Isn't it negative square root of 2? Oh, what is that one?
I'm on 11. Is it positive? Okay. 3 theta is going to equal what?
Pi over 4.
Or 7 pi over 4.
Okay. But when we solve this and divide everything by 3, okay, Okay, this is going to, it's like multiplying by a third.
5 or 12.
So it's gonna be a pi over 12 plus or minus 2 pi over 3. Can we write 2/3 as 12ths, just to humor me? 2 pi over 3 would be 8/12. This one, if we multiply by a third, becomes what?
7 pi over 12.
Plus or minus 2 pi over 3, which is 8/12. Oh, that's a 12, sorry. All right, so one solution is what? You guys can tell me one, I know you
Pi
can.
over 12.
Pi over 12.
7
Okay,
pi over 12.
add 8/12 and you get,
9 pi over 12,
what does that reduce to?
3 pi over 4.
Okay, add another 8/12 to this and you get,
17 pi over 12, and then 25 pi over 12.
okay, 25/12. What do you think?
Wait,
Too big.
Too big. Okay, we found 3 solutions so far. Now using this one down here, we'd have 7/12 plus 8/12 would be
15, 12,
15/12, which reduces by 3 to,
5 pi over 4,
and one more 8 added on there would be
23 pi over 12.
23/12. Is that less than 2?
Yes.
Okay. So were we looking for 6 answers?
Oh, yeah. I like that.
Okay. I'm glad you like it. I think it's just nasty. All right, can we do one more together though, real fast? Can we do a shift one? Let's do number 12 right here.
If we can do this with our calculator, should we? Or will we get docked?
You, if you know what 23/12 is as a decimal,
Oh, no, I have it in ratings. I got all the right answers that we just did on number 11.
What's 23 12?
that is not going to help you on the AP Calculus test, the portion where you are not allowed to use calculator, Victor.
Well, it's like the same thing. It's just a nice simple.
I think we're gonna fail that because I use my calculator.
Because you don't attempt to learn things the way I teach them sometimes. We had this problem yesterday.
Oh, what is that?
Okay. All right, I need more room, and sorry about that line there. We're just gonna have to live with it. The sine of u is negative square root of 2 over 2. Where's that true, guys?
At 5 pi over 4 and 7 pi over 4.
Only this is not equal to theta or theta over 2 or theta 2 theta. What is it equal to?
Yeah,
Theta plus pi over 3. So we're not multiplying to get rid of this. What are we doing?
exactly.
We need to subtract a pi over 3. Okay. Doesn't this look fun?
No.
If we multiply this by 3, would be 15/12. Does that seem right?
Yep.
If we multiply this by 4, this would be 4/12.
Yep.
All right, is 15/12 one of our answers? Well, except it reduces to 5/4, right? If we it's not one of our answers anyway. I forgot, we gotta subtract before we can find any of our answers, right? It might be, but. 15/12 minus 4/12 is what?
11 12.
Okay, and we still have a plus or minus 2 pi n. If we add 2 pi to 11/12, 11/12 is almost 1, right? If we add 2 pi to it, not gonna work. All right, if we do this one, we'd have times 3 would be 21/12 times 4. Okay, 21 minus 4 is
need 3 answers.
I only have 2 answers.
Oh, it can't be 5 pi over 12? Oh wait, no, that's only minus 1 pi. I'm sorry.
I think there's only 2 answers. Let's think about the graph real fast. The sine graph normally only has negative square root of 2 over 2 twice anyway, right? Between 0 and 2 pi. What are we doing to this graph?
That's 2 pi, but plus minus.
We're shifting it to the left
Left.
a little bit.
Yeah.
So it's going to do this, but it's still only going to have 2 answers before 2 pi. Okay.
Ow!
All right. I'm going to click done.